Detection of a gunshot residue. Gunshot residues may be deposited by two mechanisms: impact deposition from particles propelled by the force of the blast, fallout deposition of drifting particles that settle on a surface. Shooters have a GSR from impact and bystanders from fallen out. Deposition of gunshot residues particles following initial firearm discharge is primary transfer. Secondary transfer of these particles to other surface occur from contact with the surface or person on whom the particles have deposited, such as a shaking of hand and contact with the clothing. GSR deposition may vary by gun used to fire the bullet. Greater particle deposition with revolvers than with the automatic rifles. Greater with the non-jacketed than jacket. Samples must be obtained from the skin surface of the victim at the crime scene. Delaying obtaining residues, movement, or washing of the body prior to autopsy will diminish or eliminate the GSR. Include collection onto a carbon coated adhesive stub with an alcohol or a swab. Swab. Areas to be swabbed on GSR in case of suicidal victim on a suspect or a suspected assault. A cotton swab moistened with HCl is used to swab the hand and then treated with triphenyl methyl arsonium iodide. Triphenyl methyl arsonium iodide for detection of antimony and sodium rhodisonate for the detection of barium and lead. So barium and lead for detection, sodium rhodisonate, then triphenyl methyl arsonium iodide for detection of antimony. Antimony, triphenyl methyl arsonium for barium and lead, rhodisonate. Detection is done by dermal nitrate or paraffin test. It is an obsolete and non-specific test. It detects nitrate and nitrite from the suspect hand by removing it in a paraffin cast or cotton swab and treating with a diphenylamine reagent. A positive test is indicated by blue flecks in the paraffin. Harrison and Gilroy test is a qualitative calorimetry chemical test and not specific for firearm discharge residue, but detected the presence of antimony, barium, and lead. Dermal nitrite or paraffin test, Harrison-Gilroy test. Neutron activation analysis. This chemical method is useful in identifying minute traces of element present in the hair and nails, soil, glass pieces, paint, gunshot residue, and drugs. It is based on the detection and measurement of characteristic radioisotope formed by radiation in a nuclear reactor. Antimony and copper residues from the primer are detected from the suspect hands. Atomic absorption spectroscopy AAS and flameless atomic absorption spectrometry. This analytical method utilizes high temperature to vaporize the metallic element of the primer residues to detect and quantify them. Measuring the antimony, lead, barium and from the primer and copper vaporized from either the cartridge case or the bullet jacketing helps in determining holes in clothing and tissues as bullet holes. Range of fire, common origin of bullet fragment or shotgun pellet found at different places. Whether or not a person has fired a gun. Scanning electron microscope, energy dispersive X-ray spectrometry. SEMMEDX, which is the most sophisticated tool which can detect minute traces of GSR found on the body of suspect. It is a qualitative or not a quantitative analysis. SEMMEDX, scanning electron microscope, energy dispersive analysis. Clothing may be tested for the presence of GSR. Modified grease test is specific for nitrate. It uses chemicals alpha and naphthol to produce a visual display of gunshot residue pattern and density of particles. Rhodisonate reaction detector, lead from primer or bullet wiper. Energy dispersive X-ray. EDX detect barium, antimony, lead, copper and around the entry wound in clothing. It can be used to detect the range of fire. This is bullet entered through the scrotum on the right and exit to left to re-enter the to re-enter the medial side of thigh, two entry wound and two single exit wound. Corresponding X-ray showing the bullet. Thank you.